Welcome back to Advent of Code 2023, day 6. Hello, DJ. Yep, I am indeed later, half an hour today. Eventually we'll come full circle. Alright, day 6. Day 6. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed a large pile of sand somewhere near here. Oh yeah, we're searching for sand because you need sand for the filtration machine to make water, to make it rain back on the first island, which was called Snow Island because there was no snow. That's the story, basically. It's actually more of a story than in some of the previous years, actually. As you try to figure out what to do next, you notice a poster on the wall near the ferry dock. Boat races open to the public. Grand prizes and all expenses paid trip to Desert Island. Ooh. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. Gotta add more and more lore to confuse ChatGPT, yes indeed. You managed to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. Fine. As part of signing up, you get a sheet of paper that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. Okay. Let's have a quick look at the input. Ah. That's the whole input. Alright, so it's just 4 races and their times. Okay. And the sample input is just 3. So they're gonna do something I don't know, we'll see. Okay, the organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. Let me grab my coffee then. Okay. So they move faster if their button was held longer, sure. Alright. This document describes 3 races. The first race lasts 7 milliseconds, so that's the time limit, essentially. The record in this distance is 9 millimeters. Okay, well, okay. Input is straightforward enough. Your your toy boat has a starting speed of 0 millimeters per second, per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. Alright. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold it at all, hold it for 1, hold it for 2, hold it for 3, 4, 5, 6. Hold it for all 7. Alright, I get it. Fine. Since the current record for this race is 9, there are actually 4 different ways you could win. You could hold it for 2, 3, 4, or 5 at the start of the race. In the second race, you could hold the button for at least 4, and at most 11, and beat the record. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, if you multiply the values together, you get 288. Determine the number of ways you can beat the record in each race. Okay. Seems easy enough. Because we can work out... Alright, let's start coding this. Alright. That's... we don't really need to copy the input in. We're not going to read it from the file. Let's just, okay, we'll read it from the file. It's easy enough to pause. Alright, so times equals, so it's going to be f dot readline dot split split 1 onwards, and let's map that to an int. Read dot split. Is that correct? We'll check in a second. We want distance. So if I remember my GCSE physics, it's usually going to follow a sort of so if you plot a graph of how far you travel dependent on how long you hold the button for, it starts at 0 because they said you don't move at all if you don't hold it at all. And it's going to follow a kind of curve where it peaks over the threshold for a few different time lengths, and then it'll fall back down again, because if you hold it too long, you won't cover the distance. So parabolic arc, yeah, that's a better way of putting it. Something like that. So we can actually work out the formula. Well, I mean, how much work do we need to do here? Really, we just need to try. The times are small enough that we can just try every millisecond. We don't need to solve for x, find out the intersections of the parabolic arc with the threshold y value. I think we can just try every time value. Let's do that. So the race So define, okay, get distance for a given charge and a given race time. Charge is how long we hold it. Race time is how long the race is, because that affects it as well, because we have to cut off at that time. So charge should always be less than or equal to race time. But we can allow it to be longer. It doesn't matter, we're not going to provide a longer charge. So for the first charge seconds, the speed is going to increase to, so it would just be charge millimeters per millisecond, right? Yeah. It increases by 1 each time. So speed equals charge. So then the amount of time left will be race time minus charge. That's how much time is left, multiplied by, okay, we don't even need speed as an intermediate thing here. That's the final answer, right? So race time minus charge is the amount of time it's moving. Charge is the speed it has at the point at which it's moving. So yeah, that's a quadratic, a negative quadratic. So it's going to look like a parabolic arc, exactly, yeah. And it's actually race time. Yeah, if you think of charge as x, this is kind of k minus x times x. So kx minus x squared is the curve shape. All right. So ultimately we want the number of ways. Hello, Amaro. Yeah, this part 1 looks like I could solve it in GCSE. GCSE physics, GCSE maths, without even coding. I mean, the high school way of doing this would be just now to solve that equation against the threshold. I'll just do it the brute force way because it's so easy to code. Let's just say for time in times or charge in range time is valid, it will just get 0 distance. If so, it'll be if get distance charge time is greater or equal to distance I num okay, num equals 0 num plus equal 1, and then we just want to numways. We don't even need numways, we just need numways equals 1, and then numways multiplied by that value. Because we're multiplying all the different numbers of ways together. So they could have given a much bigger input here. Not that it would matter much, but this you can do by hand pretty easily. You solve k minus x times x equals d. So that's just quadratic equation. Find the two cutoff points, round them to the nearest integers, and boom, there you've got your left and right points. Alright, print num ways. That's not how we use map. Hang on. Oh. So this will be a list. Map object is not subscriptable. Ah. Well, we need to cast it to a list then. Yeah, that makes sense. It's an iterable, but we can't access the ith distance if we do that. And we never returned. 86190. No? I'm wrong. Oh god, it's supposed to be trivial. I might have gone too fast. I might have overlooked something. So we're trying to beat the distance record. Also, for charge in range time, well, we're allowed time plus 1, but that's probably not going to change the result. 86190, 861, okay. Print num. So we've got 26, 13, 17, 15. Does those numbers look right? Distance I, time I for charge in range. So it goes 0 up to and including time. Get distance will be whatever. Let's try it on the example input then. Oops. So that's the example. 352, 4, 8, 11. That's wrong. It should be 4, 8, 9. So 4 and 8 are right. How did I get 11? Okay. 3,200. So it's expecting... You could hold the button for at least 11 milliseconds and no more than 19 milliseconds and still beat the record. That's what they've said. So... So what the heck happened here? Charge. Ah, they've included 20. Oh, is this going to be a rounding thing? No, these are integers. 20 greater or equal to... Oh no, they said we want to beat the record. So they don't allow you to draw the record? You need to make sure you go farther in each race. Yeah, so you must need to beat the record. Strictly beat the record. By a whole millimeter. I suppose that was actually clear from the description. Okay. Fine. That's... Okay, part 2. As the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually just has very bad kerning. That's Wikipedia on kerning. Not to be confused with Kenning, Kerning Dairy, or Kerning City. There's really only one race. Ignore the spaces between the numbers on each line. So for the example from before means this. Time is that, distance is that. Now, fine, but that doesn't seem... I mean, that's still 70,000. That's still pretty easy to work out by hand. Very easy to work out. But it's even easier to work out by hand, because now there's only one race you need to solve the quadratic equation for. Plus, we can still do it with brute force, because it's still in the tens of thousands, right? Let's just see. I could just plug in... I'll try and write it so that it actually uses the... Oh, but it's not going to be 70,000. It's going to be 40 million. That's still okay, to be honest. It's a bit... It'll take a while, but... if it takes too long, I can just solve the quadratic equation, but... Okay, so how do we... Right, part 2... So this was part 1. So we need to take times, so t equals so it will be join turn all these times to strings, join them up, and then turn that back into an int. Same goes for distance. Could be distances, but and now we just do this. Just that. Okay, it might actually take a while, but whatever. Meanwhile, okay, there we go. Should be right if the first part was right. Unless I've... Correct. Okay. I mean, that could have been adjusted so that brute force wouldn't work, or at least would take a bit longer. You could quite happily do it in the billions or trillions because, yeah, I think you missed a trick there. It would have been a much better problem because then you just got to actually work out the shape of the parabolic. Solve. I mean, should we do that? Just to see how you would normally do it. It would be... So the equation is... We want to find where... that... So we're solving... T minus C times C equals D. So that will give you 2 points. 2 valid points for C. So that's the same as TC minus C squared equals D. Move things over, so that's C squared minus TC plus D equals 0. So you solve that equation. Yeah. So then you have to use the quadratic equations. That's minus. So it's going to be T plus or minus the square root of T squared minus 4D all divided by it's b squared minus plus or minus square root of 4 all over 2a, so it's going to be 2. So basically first we find this bit here, so it's going to be math, so it's going to be actually square root is a okay. So it's going to be math to square root T squared minus 4 times D. So T1 equals... No. Why am I switching between C's and... Yeah. C1 equals T plus temp. I mean, this is taking me longer to code, clearly, than the brute force, but this is how you would do it if it was in the trillions. Did not know that was squared in Python. Yeah, that's exponentiation raised to the power. Because the carré symbol is reserved for bitwise stuff, bitwise operations. T plus temp. Okay, so we'll do this as a floating point number. C2 equals T minus temp over 2. Let's call these C2 and C1. C1 will be the smaller one. Okay, hide all this stuff. So then print C1, C2. We have to wait for that all to do. So that's C1 and that's C2. So if the curve is crossed between them, then we need to take basically int of C2. We need to round down for that, and we need to round up for C1. Alright, and that should hopefully give us the same answer as the brute force approach. We're off by 1. Am I rounding correctly? So we want ceiling of C1, because we can't... If it crosses at 0.23, then clearly if we go left of that, it's going to be too low. And C2 we round down, because if we go higher than that, we would be too high. Oh! Yeah, you do add 1. That's you're supposed to add 1 when you want to have an inclusive range. Yeah, that's fine. So yeah, that is what you would do, which you could do that at GCSE level. GCSE is the British equivalent of American high school level, on pen and paper, even if it were in the trillions. So yeah, this is... I'm surprised he didn't go for much bigger numbers here. Definitely could have made that harder, but okay. He wanted to clean this up a bit, because I'm going to post this on my Gist page. Just say... But I mean, that can be encompassed in a method which is the better get distance. Well, that took me, what, 20 minutes? I wasn't... Okay, so, nice easy one, which is good because I started late today. So you always get a natural drop, even if it's an easy problem, because a lot of people kind of, especially after yesterday's problem, get discouraged and just stop doing Advent of Code. So it's hard to tell. It's easier to tell when things are super hard, because then there's a massive drop. But it's hard to tell when things are easy, because then it's just not as much of a drop. So it's hard to interpret this. But we can see that there was a high proportion of people who solved part 2, who solved part 1, which is... I mean, there's no excuse, really. If you solve part 1, you can't really trip up over part 2. So this was the easiest problem this year, for sure. I'd argue one of the easiest problems in the history of Advent of Code, based on the fact that high schoolers could solve it without code. So that's the leaderboard. My personal leaderboard. And there's one other one I joined. Some streamers. I think he's using C#. Ria is lady who got me into Advent of Code. I think she's disappeared from Twitch altogether. I haven't seen her in years. Maro is missing a day. Today's day, yeah. Did you solve it, Amaro? And that's I reckon. Yeah, I was gonna say I don't actually expect this to be faster than day 2 because no, which one? No, not day 2. Yeah, day 2. Because day 2 was solved in a phenomenally fast time, 1:34. Actually, no. The fact that you could just type in the numbers by hand and quickly use the quadratic equation, you could literally pull up a Python. No, not Python. You could literally just type the quadratic equation into Google, and Google would solve it for you. Yeah, 2 minutes is actually longer than I thought it would take the top coders. Like, I'm pretty sure you could just type it into a calculator faster than writing code at all if you were aiming for the top spot. 1:15 for the first problem. I guess they'd had to spend a bit of time unpacking that description because it was quite wordy. The simplicity may have confused people, yeah. They may have started coding stuff before they realized. Yeah. But yeah, I'm pretty sure you could just type the... I don't know if Google could do it, but I'm sure you could do it into like Wolfram Mathematica or something. You just type in the equation, it will just spit out the answers. But... And that's allowed, because it's not an AI, so it's not exactly interpreting the problem, it's just calculating the answer to an equation you're giving it. So you're allowed to use stuff like that. Okay, that's actually slower than I expected, but fine. Alright then, so what do we expect tomorrow? Tomorrow will be another hard one? What was day 5 again? This was... Oh yeah, this map thing. Also, Amaro, you managed day 5. See, I saw some people did a sort of brute force approach to this and it worked, but only for some inputs. They basically looked at all the locations, started from location 0, then location 1, and location 2, and just pushed it back through the maps to find what the original seed was, until they found a hit, and that actually worked for some inputs, but some other people it didn't work, so it seems like the input was slightly not, well, kind of unfair in the sense that brute force works for some people and doesn't for some other people, but I mean, you're supposed to, well, I don't know. Okay. That's all then. See you tomorrow. Okay, and I won't be spending several hours today solving code. That's good. I can have my day back. Alright, see you guys. See you guys tomorrow.